All right, good morning, you guys. Today we're taking on chapter 6.4, Sampling Distribution of a Sample Proportion More. All right, so starting with example 1. A 2017 Gallup poll interviewed an SRS of 1,200 Americans by phone. They were asked, do you frequently experience stress in your daily life? Of the respondents, 360 said yes. Find each of the following. So what is our population first? So what is our whole group that we are interested in knowing about? Well, we're interested in Americans, right? That's as simple as we can make it. Americans. Okay, likely American adults, but we'll just leave it at Americans. Okay, the parameter, so again, notation, little p right there. So we're looking at the number that describes the population. So the proportion of Americans who frequently experience stress in daily life. Okay, so again, our population, that whole group that we want information from, all Americans. What is the number that describes the population? Well, that is the proportion of Americans or percentage of Americans who experience stress in daily life. Okay, the sample, what is the subgroup of the larger population that we actually have information from? And we have information from the 1,200 Americans. Okay, and then our statistic, that little p hat. Okay, here let's look for the number that describes the sample. So we're told that 360 said yes. So 360 out of the 1,200. So if I write that as a percentage, that would be 30%. So here I'm saying 30% of Americans, really those Americans that are sampled, experience stress in daily life. So again, our population is the whole group that we're interested in learning about. Our parameter is the number that describes the population. We do not always know the parameter. It's elusive. It's what we're trying to estimate, what we're trying to predict. Our sample, we concretely have information from a subgroup of 1,200 Americans, and the number that describes our sample, our statistic, is the 30% of those sampled, right, all Americans who experience stress in daily life. Okay, next up. Here we go, example 2. In the game of Scrabble, each bag begins by drawing 7 tiles from a bag containing 100 tiles. There are 42 vowels, 56 consonants, and 2 blank tiles in the bag. Caitlin chooses an SRS of 7 tiles. So that's telling me that's the N value, 7 tiles. Would it be appropriate to use a normal distribution to model the sampling distribution of the proportion of vowels in her sample? Check the 3 assumptions. Okay, so we're looking at, in our situation, we're trying to figure out the proportion of vowels in her sample. Would it be appropriate to use a normal distribution to model that distribution? Okay, so first we're saying, well, do we have randomization? And when I look here, I see that beautiful word, or words, right? SRS. So simple random sample, then check. There we go, right? It mentions an SRS. Okay, next we're looking at the 10% condition. Okay, we want to make sure that our sample is less than 10% of the population. So here we are looking at, let's see, 7 tiles out of 100. So 7 out of 100 would be 7%. So we're saying, yep, that looks good. Here we know that our sample is less than 10% of our population. Okay, lastly, we have to check the success-failure condition. So here we're looking at, do we have enough successes? Do we have enough failures? So to figure that out, we're looking at n times p. We want it to be greater than or equal to 10. So here we're looking at the number in our sample multiplied by the probability of success. And then NQ also has to be greater than or equal to 10. So the number of in our sample times the proportion of failure. We know that the quantity then of failures has to be greater than or equal to 10. So here I'm going to plug in 7 for my n value, right? My sample size is 7. Here the proportion here of success of getting something that's a vowel. So a vowel is 42 out of 100. So I'm just going to leave it like a fraction like that, not simplified. And when I multiply, I'm going to end up with 2.94. So right away, that number is not greater than or equal to 10. So this condition is not met, but I'm still going to show my work over here as well. So here I would have 7 in my sample. Q is my probability of it not being a vowel. So that means it could be a consonant or a blank tile. So 58 out of the 100 is going to get me 4.06. So again, right there, these two numbers, they're not equal to or more than 10. So a normal model is not appropriate. All right, next up. According to a 2016 Pew Center poll, 33% of Americans report that they exercise on a regular basis. Suppose an SRS of 45 Americans is chosen. Would it be appropriate to use a normal model to model the sampling distribution? Calculate the mean and the standard deviation. Check the 3 assumptions. So the mean, first, let me just underline the key details here. We're told that 33% of Americans report that they exercise on a regular basis. So it's giving us our p-value. We're told that there's an SRS of 45. There's our n value right there. And then again, we're trying to decide, is it appropriate for the distribution to be normal? So my mean of my statistics, right, my sample proportion, should be equal to that p-value right here of 0.33. Okay, the standard deviation, square root of p times q over n. Okay, so square root of 0.33 times 0.67 all over 45. So that's going to get me about 0.0701. So my standard deviation would be about 0.0701. Okay, and then checking my 3 assumptions. So first we're looking at the randomization condition. And of course it mentions an SRS right here, so check. Okay, next up we're looking at the 10% condition. So here we're looking at 45 Americans that are chosen. right? I think we can all agree that 45 Americans is dramatically less than 10% of all Americans, so we can check that guy off as well. And let me just write what I said off to the side. 45 Americans is way less than 10% of all Americans. Okay, and then lastly, success-failure condition. So here we're looking at n times p greater than or equal to 10, n times q greater than or equal to 10. So n, right, my sample size is 45. The probability of success here is the 33% of Americans who exercise on a regular basis, so 0.33, and I get 14.85. Okay, so absolutely, I have enough successes. So then over here, n times q, so 45 in the sample. Probability of failure, complement of success would be 0.67, and then I multiply 30.15. So we can see that we are well above our threshold, right? We definitely have greater than or equal to 10. So we can check off right here, and since the three assumptions are met, we can say now that a normal model is appropriate. Okay, so again, I'm just starting out by having you refresh yourself on how we get to the mean, how we get to a standard deviation of a sampling distribution of a sample proportion. So when we check the three assumptions, we're just making sure that our distribution looks normal to then push forward and then calculate a certain probability of an event that could play out. So that's what we're going to see on the flip side. So take a moment, flip it over, or take out that second sheet. All right, so here is where it gets new. So example 3 is just a continuation of what was on the other side. So on the other side, we solved for our mean, we solved for our standard deviation. Let me carry those over from the other side right here. The mean was 0.33. The standard deviation was about 0.0701. Okay, so again, carried over from the other side, and we also checked, we did check our three assumptions just to make sure that a normal model is appropriate. Okay, so now we're going to calculate certain probabilities. So find the probability that at most, 27% of people in the group say that they exercise on a regular basis. Okay, so let me draw my normal curve. I'm going to mark where the mean is, right there. So there's that 0.33. So I'm just keeping my eye on that marker, right? That is my mean. That's right smack in the middle of my normal model. Okay, at most 27%. So let's see, I'll put a little marker here, 0.27, and it's saying at most. So I'm looking at the percent that would fall in this lower tail. That's my goal here, okay? And then I'm going to just think of that now as a probability of this scenario unfolding. So we have used our calculator, we've used normal CDF, we've used it with z-scores. And then in our lecture from our previous portion of this section, right, in 6.4, I showed you how you could do it with the raw data itself. So when we're doing it with the raw data, remember, we're still looking at normal CDF. We're looking at that lower boundary to the upper boundary, mean and standard deviation. Okay, now when we were doing z-scores, our lower boundary, right, we always did -99, right? That was our placeholder for infinity. So now that we use raw data, we usually just go a little bit further. So I'm going to use negative 999 as my placeholder for infinity. So here I'm going to type in normal CDF, negative 999. Again, that's my placeholder for negative infinity way over here. Okay, my upper boundary right there, the 0.27. The mean is 0.33. My standard deviation, 0.0701. So that's going to give me the area that's under my normal curve. And I'm going to think about that as the probability now that at most 27% of people in the group say they exercise on a regular basis. Okay, so here I'm just going back to normal CDF. Negative 999, my placeholder for negative infinity, to 0.27, and then mean and standard deviation. Boom. So here we get 0.1960 or 19.6%. All right, next up, find the probability that at least 34% of the people in the group will say that they exercise on a regular basis. So at least 34% this time. So let me draw out my normal curve. Right, those three assumptions have been met. Right smack in the middle is my mean, the 0.33. And then we're looking at least 34%. So I'll put a little notch here, right, 0.34. And then at least means right here and anything above. So again, I'm looking for what is the area in this region under my normal curve. And I'm just going to think of that as a probability for this scenario right here playing out. So here I'm going to do normal CDF, 0.34. That's my lower boundary. My upper boundary is really infinity, right? But we use a placeholder for infinity, so I'm going to use positive 999. Mean, 0.33. Standard deviation, 0.0701. Let's type it in. So 0.34 to 999. Mean, 0.33, standard deviation, 0.0701, and here we go. So 0.4433 or 44.33%. Okay, if more than 50% of people in the group say that they exercise on a regular basis, does this seem unusual? Explain why or why not. So I'm going to underline that because that part is different and that feels important. So I'm going to do the same thing. I'm going to draw out my normal curve. I'm looking at more than 50%. Put a little notch right here, 0.33. Right, that's where my mean is. I'm going to mark where about 0.5 will be, right? Just a visual reference right there. And then it's saying more than, so I'm still in that upper tail. And again, I'm going to draw on the infinity right there to remember that this is my lower boundary, here's my upper boundary. Okay, and then I want to think, well, what would make something unusual? When would I think that this result would be unusual? And right now, my criteria that I'm going to hold you to is it's unusual, it is unlikely if it's less than 5%. So unusual is if the result is less than 5%. So result unlikely if less than 5%. So it would occur in less than 5% of the time. Okay, so let's solve for it. Normal CDF, 0.5 to 999. Again, that's my placeholder for infinity. 0.33, 0.0701. So let's crunch that together. Here we go. So normal CDF, 0.5, comma, 999, comma, 0.33, comma, 0.0701. There we go. So we get 0.0077 this time. So that would be about 0.77%. Okay, that seems unusual, right? It is less than 1% of the time that we would expect this scenario to play out. So let me write that nice and clean as a summarizing statement. So we'd say, yes, unusual. Because about 0.77% of simple random samples of size 45 would have 50% or more individuals who exercise on a regular basis. Okay, so let me just unpack that one more time. Okay, when are we making it unusual? We're saying, we're going to right now say, it's unusual if we're seeing a figure that is less than 5%. Okay, so we came up with less than 1%, 0.77%, so less than 1% of the time. So we're saying, yes, unusual. 0.77% of simple random samples of size 45 would have this result, would have 50% or more individuals who exercise on a regular basis. All right, let's push up and go to our last one, example 4. Okay, in Major League Baseball, 25% of players are left-handed. You take a random sample of 50 Major League Baseball players. Find the mean and the standard deviation, check the 3 assumptions, solve for each probability if a normal model is appropriate. Okay, so we're looking at 25% of players are left-handed. So it's giving us our p-value right there. Our sample size right here is 50. That's our n. All right, calculate the mean, calculate the standard deviation. So our mean would be 0.25, right? We're expecting 25% of players being left-handed. Okay, standard deviation. So square root of PQ over N. So here is P, here's its complement, Q, divided by the 50. Okay, if I plug that into my calculator, I'm going to get about 0.0612. So my standard deviation would be about 0.0612. All right, check the 3 assumptions. So first, do we have randomization? Usually it either says the word or it talks about an SRS. So let's see. We see the word random, right? It uses that word random right there, so check. Okay, next, 10% condition. So here we just want to make sure that our sample is less than 10% of our entire population. And a sample of size 50 absolutely would be less than 10% of all Major League Baseball players. So I'm going to say check and write what I just said. So sample of 50 is less than 10% of all Major League Baseball players. Okay, check success and failure. So is NP greater than or equal to 10? How about NQ? So if I plug in 50, that's my sample size, times 0.25, right? That's my probability of success, the proportion of lefties in Major League Baseball. And then what does that equal? 12.5. So we see that we have enough successes. We have 10 or more. Okay, NQ, so 50 times 0.75, right? Failure is the complement of success, and that gets me 37.5. So check we go. We see that we have fulfilled our 3 assumptions. So we know that it's going to be big enough, but not too big, right? We keep saying that. Big enough, but not too big. We want to make sure that if we were to look at this, that a normal model would be appropriate. So we're saying, yes, normal model is appropriate here. Okay, so then we push forward and we answer the final questions. So let me push up to here. All right, so what percent of samples will have between 20 and 30% left-handed Major League Baseball players? So let's picture that. So 0.25 right here, that's where the mean is. That's the proportion of lefties that we're going to expect. And then over here, we're looking at between 0.2 and 0.3. So I'm looking within that span. So I'm going to do normal CDF, 0.2 to 0.3, right? Lower to upper boundary, mean and standard deviation. Okay, if I plug all that into my calculator, that would get me 58.61%. So in 58.61% of samples of size 50, right, we would expect to see between 20 and 30% lefties. Okay, for D, is it likely that you will see a sample with less than 12 lefties in Major League Baseball? Explain why or why not. Okay, so we're looking at less than 12. So let me draw that out. Normal curve, here's my mean, 0.25. And we're looking at here, 0.15, and that lower tail. And remember, my placeholder for negative infinity will be negative 999. So I'm looking at normal CDF, negative 999 to 0.15, mean and standard deviation. Okay, when I crunch, I get 0.0511, so 5.11%. Ah, we're right on the cusp. Let me make a note of that. Right on the cusp. Right? Remember that we keep saying it should be less than 5% to be unusual. So what happens when it comes in borderline, right? We don't always have perfect situations and perfect data, right? We say as a loose rule, should be 5% or below, but these cases that come in right on the border, we just take a careful eye when we look at them. So here I would say, yeah, we're still pretty close to that 5%, right? We're really just a tenth over it. So we're going to say, yes, it's on the borderline of being unusual. Okay, and the reason, well, because we're saying about 5.11% of samples of size 50 would have 15% or less lefties. So again, today we refreshed ourselves on what we've been doing. We know how to check the 3 assumptions to determine whether a distribution appears normal or not, whether it's appropriate to use or not. We know how to calculate the mean and the standard deviation, and we know how to calculate probabilities of certain events that could play out. And we know that if we're deeming something to be unusual, we're saying that it's unlikely to get this result when it's less than 5% of the time that we would see it play out. All right, I hope you guys are all doing well, and I hope to see you soon.